where the line touches, like where the points are touching. Because that's kind of what it's doing. If you like notice 25, that's what it's doing.
Yeah, so you need to show me a table of values, is that what you're asking?
Yeah,
just like we did. Just like we did. Okay. Yeah. Because if it just comes out of nowhere, I'm not sure where it's coming from.
So 24, for instance, needs to have a table of values.
Yep. Okay. Cool. Or some other way. You could either do like the book does, and they graph it on the XY plane first, and then they graph, and then they use those values. But to me, you need a table for that sort of anyway for some of these.
Okay.
So the most direct way to do it is to give me a table and then plot the points. Yeah, because your calculator, I showed you how to do it. So, like always, I want something to show me that it actually came from your... You could check it on the calculator all day long. But I don't want you just copying it on the calculator. That's kind of not good. I don't need to check if your calculator knows how to do it. It was programmed to be so. So it will. As long as its batteries are good, it can do it. Any other questions for me? All right. Tony, you got it? Tony's like, somebody ask. I don't have any. All right. All right. Just no other questions. We're going to get back into it. Yeah, so like 8.4, you just got to get in there and try it out. If there's no questions from there, I'm not really sure what to do with you guys. 8.4 really, fundamentally, it's when you go to plot them, it really is just make a table of values, pay attention to what they say t can be. Very often they'll give you a domain for t, for the parameter. Sometimes they don't, which is fine. That should mean something. But very often they do. Let's see. Well, one thing we didn't do, we'll do a little bit of right now. If I give you an equation, can you come up with a set of parametric equations for this? There's an easy answer, a quick answer, and then there's like an infinite number of other answers. So let me see if you guys can get this. All right, ready? What's it mean to be a system of parametric equation? I mean, what the hell is that? What's the parameter? Normally, what's the parameter? What letter is given to the parameter? T. All right, good. We'll start there. All right, cool. And what does that parameter do? How does it act? What do we do with it? Plug it in. Plug, you mean the boundary. What do we do with it? What does it do? So for example, let me give you an example. This equation has variables x and y, and when I plug stuff in for x, I get values for y. Alright, can you see something sort of like that, but with x and y and t? When I plug in values for t, I get both x and y. Yeah, I have to plug in something for the y equation, so it'll be y in terms of t and x in terms of t, right? So this one we normally consider x to be the controller. I change x and y changes corresponding to what x did. I like the idea that... have you guys ever taken statistics? Anybody? Oh, cool. A decent number of you guys. And the rest of you are like, don't say any shit, man. I haven't taken it. So there's an idea of, for example, I noticed, so I feel like I've said this already to you guys. I sell ice cream. And next to me there's this guy that sells water. And yes, that's the way I say water. Somebody always tells me I say it weird. H2O. He sells some high quality H2O right next to me. There we go. I like the reference to him. And I noticed that every time he sells more water, H2O, I sell more ice cream. I'm like, holy crap. For some reason, selling water makes people buying water makes them also want to get ice cream. Now, of course, it's bullshit. What's going on, probably? When would they sell more water? And when would I sell more ice cream?
Really hot day.
Because the temperature increases. So both the water, and I thought that the water was causing my ice cream sales to rise. As the water sales rose, so did my ice cream. And I'm like, why would that be? Holy shit. It's like thinking that basketball will make you taller because you watch a lot of basketball games. Holy shit, basketball makes you tall. I'm going to start playing basketball. I'm sorry, it's not going to work. I tried. And I got to here. Right? So, you guys, this is kind of a silly example, but in real life, this is really difficult for statisticians to figure out, is something causing something else, or are they both being caused by some third factor? So I love this is beautiful for that. There's a third factor behind both of these. So X is changing, but it's not independent. Y is obviously dependent on X the way I've written this, but X is also dependent on something else, like the temperature. You guys semi with me? Semi? I can't cut that much. Too much more. 116? Alright. So the simplest way to create a system of equations. This is neat. This is always a good idea to try to do this backwards. They give you the equations in the book, but let's try to create our own. The simplest one would be x equals t. Whoa. And so what would y be?
Y equals
T squared? That's craziness. So if you plug these in your calculator in parametric mode, it'll graph this graph. And of course, what does this graph look like? Parabola. I love it. Upward facing parabola. Cool. Well, very difficult yoga position. You're not even like buttering me up. You actually laugh at that. It's really stupid. Yes.
So they have to give you like what x is or find y.
Say again.
So your question is like how you're supposed to go from just y equals x squared minus x to the parametric?
Sure. Is this the only way to do it?
No.
Well, how else could you do it?
They
Man with a plan. How else?
Because they're going to give you y and then you can find x to, like x, whatever that equals to.
That would be difficult. You mean define y first in terms of t?
Yeah.
Why would that be difficult in this example? Because if I make y equal to t, how do I solve for x? Quadratic formula with freaky ass t thing in there for a constant. I don't want to do that. So the way this is written, I want to start by defining x as some function of t, and then I can figure out y. So this is one way to do it. Another way to do it is x equals cosine t. Why not? Now the minute you do that, what's the highest and lowest x could be? 1. So you're not going to get the whole parabola if you do it this way, are you? You're only going to get some little smidgen of it, right? Think about that. Here, how large could x be? As big as t is, right? Here, no matter how big I make t, x can only go from -1 to 1. You're only going to get that much of the parabola. Does that make sense? So, something you guys need to understand. I'm glad I'm doing this, glad I remembered to do this. Not only are you fed parametric equations, you can create them yourself. And very often there's a reason. Very often it's because there really is like a T is temperature. And you're actually trying to find the actual equation of it. But sometimes you're allowed to just play with it and just make it whatever you want it to. But you got to understand the consequences of your choices. Right? With great flexibility comes great responsibility. It's great. So if x was cosine t, what's y? Cosine squared t minus cosine t. I think you guys get the idea now. There's a lot of flexibility, but anytime there's flexibility, there's got to be something taken away from you at the same time. And it's whatever you choose, its domain and range will screw you up, possibly. If I want the whole parabola, this is not a good way to go. So you can imagine, you can make x whatever function of t you want to if you don't care about such things. Right? You can make x square root of t. You can make x natural log of t. You can make x e to the t. And every time you do that, you can figure out what y is going to be, right? Not a big deal. All right, good. I want you to realize that. You don't have to be fed these. You can create these parametric equations yourself. Kick ass. You can make x equal to e to the cosine t. Holy shit, that's some weird shit. And just try it and see what happens. All right. Blah, 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 blah. So the other aspect of that, I think the hard part sometimes is going to be, let me see if they give you something freaky here. Rewriting it in terms of rectangular coordinates. Ooh, that looks gross. Well, let's try this here. give us here, rewrite in rectangular form. Yeah, Jeff, change that one letter. Forget that all of them, the other ones look crappy too. Well, this one's, let's start off with this one. This one's not too bad. I like that. So this is the other way around. You're being fed parametric. What rectangular equation did they start with to create this? What's the connection between those? And I'll tell you, they tell us that t is between 0 and pi over 2. There's actually a few different ways to do this. There's a very direct way and a very indirect way. The second way I just remembered right now, because they never really do it that way. But we'll try it. We'll see if it comes out the same way. All right. Can anybody tell me, if that was secant squared, maybe this would be easier. What connection is there between tangent squared and secant squared? 1 plus tangent squared is secant squared. So then secant is the square root, especially because we're in a place where everything's positive. You with me? Otherwise, you have to worry about the plus or minus bullshit, right? But they told me I'm in a place. I'm in the first quadrant. First quadrant is a beautiful place to live because everything's positive. Yeah. Right? That sounded really crazy. Well, your meds are, I think your meds are playing off each other, Jeff. All right, I'll be all right. So say what you just said. Tangent squared, t plus 1 is secant squared, right? Which means secant is, you can do it? Square root of tangent squared. What's secant? X. In this equation, in this parametric equation, secant t was what x was called. And what's tangent squared? Y. That's crazy. That's crazy talk. And then you can actually just take the square root away. You didn't really need that. X squared is y plus 1, so y is x squared minus 1. Let me let you absorb that for a minute. So when you first look at this, it's not at all obvious that it's a parabola shifted down by 1. There's no way to just look at that and know. And just to remind you, in this homework, the first part is graph it. So you will have already graphed it. So at that point, you'll know. You'll know what to expect the equation. You'll have graphed it. You'll go, well, that's a freaking little piece of a parabola. The equation's got to come out like that. Maybe you guys semi with me here? When you're trying to... Now, here's the second one. Well, one way you can do it is to figure out, is there a relationship between these two already? Does the relationship exist? And yes. But another way to do it is just to take this and solve for t and then plug it in this guy. And that's the way I don't personally like too much. But it's the way that I understand a lot of students like, because it's very, boom, just do it every time like that. But you got to be careful when you do that. What the hell does that mean? I don't know, shit. Let's see. Like I told you, just thought about this. So here's a second way to do this. Stay with me now. What do we know the minute I write this? Right, that's x. What could I do the minute I write that? What am I allowed to create based on that expression, based on that relationship? You could get cosine, sure. I like it, because cosine would be what? Sure, so you can say 1 over x is cosine. Is that cool? That only makes sense, because cosine is 1 over secant. Alright, cool. I like it. What's something better you could do, considering that I want to get y, which is tangent squared? You could take the inverse cosine I don't know, maybe that'll spur some of us to realize.
Yes.
You're fine. Does that look, remember what we talked about with the inverse trig? What can you always create? I don't care if it really exists anywhere in the universe. What can you create? Triangle. Holy shit. And some of you guys in your face, you're like, that's what I was thinking. You should have read my brain if I could do that. It'd be so much easier to teach. No, you're thinking wrong. So what can I label? So I'm going to create a triangle that represents this idea. So here's my angle T. What can I label in that triangle? Considering it's from inverse cosine, what can I label?
X and y.
Yeah, the x piece is 1. Hypotenuse is x. And now the question is, y is tangent squared. Well, what's tangent? So what do I need? Good. What is it?
X2, no, 1 is the second.
Minus 1. I like it. 1 is 1 squared. Is that cool? That's just Pythagorean theorem. Alright, I like it. Joseph. So then what do you get here? What's the tangent?
Square root of x squared minus 1 over 1.
Over 1. So that's the tangent squared. That's the tangent squared. You with me? And what do you get when you square that?
X squared minus 1.
Holy shit. Holy shit. Well, of course, on the other level, it's like, well, yeah, Jeff, shit, you start in the same place. Of course, you're going to end up in the same place. But it's neat, as a student, to realize there are completely different ways to get the same answer. That's why math is not so black and white. There's so many, in fact, it's not even that. Math has a lot of ambiguity to it. But even in the case where there's one right answer, there's multiple ways to get there. It's neat. Okay. I don't know, hopefully you guys picked up on what's happening. So you can always, if possible, you can solve one of these for t and then try to plug it in the other dude. With trig functions, that's going to involve inverse. Ooh, I can draw a triangle. I can go that way. No problem. Or is there a very simple or some kind of relationship between these two? Right? So for example, here's one I hope you wouldn't have to do this way. Well, I like the way I put that. This is the reverse of what you're used to, but too bad. I can define x any way I want to. So I can define x to be sine and y to be cosine. Just to be annoying. What's the relationship between sine and cosine? What's the most fundamental relationship between the two of them? Sure, sine divided by cosine is tangent. But yeah, sine squared plus cosine squared equals 1. And what's sine squared? X squared. And what's cosine squared? Y squared. So that would be a circle. So if you put that into your graphing calculator in the parametric mode, x equals sine t, y equals cosine t, and you gave t a large enough, obviously t would have to go from what to what? 0 to 2 pi. It's crazy. It's how long it's going to take to get around a circle. If you do that, you'll get a circle. It's crazy. Of course you will, because it's that equation. It comes from that equation. Now, this is not the only way to describe this equation, but this leads only to this equation. No matter other way you do it, what other way you do it, it's going to lead to that equation. Okay, maybe. All right. To me, that's the harder part of this. One part is just plug and shove. You got an extra t variable in front of x and y. Ooh, that should not be a problem in any way. You can plug a t in, get x and y, and plot points. That should not be the problem. To me, the problem is going to be how the hell to get from this to this. That's the weirder part. And that's where you have to realize I can use relationships between the two of them. I can solve one for t and plug it in the other one, which could involve some weird-ass math. But, oh well, I can try that if I can't see anything else. All right. One more example, and then we'll get into chapter 10. Oh, yeah. What if I had this here? Ew. That's gross. And I want to know, what is the rectangular form of this parametric equation set? Yeah, like if you want to know, Jeff, you can figure out, man. But which one of these is easier to work with? Yeah, so what's the most basic way? Is there a relationship between these two? I don't see any freaking, I don't know. Shit. So what do? Yeah, take this one, solve for t. I'm going to add 7, divide by 3, and plug that in wherever I see t. So I get x is y plus 7 over 3 squared minus natural log of y plus 7 over 3 all over e to the y plus 7 over 3 minus 2. Oh, yeah, that is yummy. That was creepy, John. Oh, these things happen. That was creepy. Gross! There's really not that much you can really fundamentally do. I mean, you could, this is 9, you could bring a 9 down, put a 9 there. I mean, it's not much you could do to simplify that. So I'd be cool with stopping there. It's a really weird looking thing. Cool. So you could put these in your calculator. Why can't you put this in your calculator? What would you have to do to put this in your calculator? You'd have to solve for y. You want to try to solve for y? Look at where y is. Holy shit, there's no way to get all the y's down and out and together. There's no way. So if you do this in your calculator, if you plug these in, your calculator is going to graph something that's not a function. But parametric equations are cool with it because they are functions of t. They're just not functions of y and x. They're not functions of each other, y and x, like they normally are. Maybe. X here is actually a function of y, but that doesn't have to be the truth. Okay. Hopeful. All right. You just got to get in there. You just got to get in there and try it. You're not going to see much of that, though, by the way, in the homework, so don't freak out. I want to give you one that's really, really ugly. That's actually, you just work with the one that's easier to work with. That makes sense. Okay. So, chapter 10, after all the freakiness you have been through, chapter 10 will be a breath of fresh air at first. How many of you guys have ever worked with, remember I just said it first, how many of you guys have ever worked with matrices? Alright, so depending on your 110 teachers, some 110 teachers don't work with matrices. So I'm going to assume that you haven't. I'm going to start from the basics. But, yes?
Well, we're going to finish this in class, and you're supposed to finish this alone.
Yeah, we could finish that. I forgot. Where did we leave off?
Number 1.
We graphed that bad boy, right?
Yeah.
Yeah, so we left off at number 2?
Well, yeah, I guess. The last thing we did was number 1.
Alright. But yeah, look at number 2. Based off of what I did up here, what would you do on number 2? This is that handout from section 8. Yeah, which one?
Y. Solve.
Yeah, I couldn't solve x for t.
And then plug it into x.
So I'm going to, yeah, exactly. So number 2 is pretty easy. Take the y equation, solve for t, plug it in to the x equation. And then the last one, I do want you just to play around with that yourself. Did anybody try that last one out? Anybody?
Is that the same thing? Like, do you want us to...
No, I just want you to graph it
graph those two?
and then describe it. It's kind of nifty. And the really nifty thing is, and in fact, let's do this. If you have a graphing calculator, plug in that last set. If you don't, look on with somebody near you that has one. Go ahead and plug those in. Be careful if your calculator opens parentheses for sine or cosine. Oriented how? Beautiful. It's a rotated ellipse. Kick ass. So if you try to solve it into xy terms, and if you try to put it into rectangular coordinates alone, it would not look very nice.
Are we still in polar?
Totally. Yeah. Let me make sure. If you're trying this out, let me know. You should get something. If I remember correctly, it's tilted this way, right? Oh, thank you. All the poor college students watch you as you come in with a giant box of cookies.
I know. Say nothing, it's just not out.
Just to show you what you're going to miss out on later. Are you guys able to get that? It should look like an ellipse that's been rotated. Alright, now if you have it in there, try to change the y one from 5 cosine 2t, make it 5 cosine 3t. I think that's what I did last time, before class. What happens? Oh yeah, cool. Yeah. What do you mean he's nasty? You said it's nasty. No, that's cool. Nasty. It's like some superhero's logo or something. I am blah man. You guys get me? So I mean, I hope to God. I mean, this is sometimes a stretch. If I'm first learning this, I'm going to take my calculator and just for like a couple hours, just put 20 in there. See what the hell happens. Instead of 3, put 11. Put square root of 7. I don't know. Change the other equation 2. See what happens. Tell me if you get something that looks really weird, right? If you want to. It's nothing you have to do. You just have to do the homework. That's all you have to do. But what should you be interested in and curious about is what the hell happens when I make it this? What changes when I make it that? Make it y equals 5 cosine 2t plus t. Shit, what the hell would that do? I don't know. Shit, try it and see. It's really neat. Can be really neat. If you do plus t, it'll probably do something weird where it's... Now that I'm curious about. Can somebody do that for me? Make it 5 cosine 2t plus t. You alive? No, look over it. Okay. Try this one. Same thing?
Yeah, it just makes it bigger.
Oh, no. So the plus t on the outside. Oh, it's just easy. There you go. Now we're talking. Sorry. Freakiness. Okay, so then your window, you want to be from like 0 to 2 pi probably. That'd be correct. And you're zoomed way. Whoa, let's try. Oh, what mode are you in? You're in degrees. Your window's on. We'll see. Oh, your line is like... Alright, this is freaking me out. Come back. Stop. Goodness gracious, what happened? Your line was from 4 to 5. I just went to 5 to 5. Okay. There we go. Look at that dude. Now watch. I mean, it disappeared. Now, if you guys equal to 5 cosine 2t, close parenthesis at the end, plus t. It goes up. Yay! Sorry. I'm easily amused. And you're like, well, we are not. I noticed that about you. There's one thing I know about you. You're not easily amused.
Or it could be that it's a trigonometry.
You're not easily amused by math. At least will be. Alright, so hopefully, maybe somebody out there will be curious. I always like it when it does that. It's sort of like what I was talking about when you draw a circle. Now, if you add a third dimension to it and let that third dimension, it'll be like a spring. It'll come out at you. And you sort of see that, especially like the window. If you make the t range from negative 4 pi to 4 pi, then you'll get the whole wee-ha. It'll just be spiraling up. Yeah. Now imagine that in 3 dimensions. Cool, man. Imagine that in 4 dimensions. Stop. Your brain will explode. Don't go to 4D. All right. Okay. So that's enough of it. So hopefully guys will understand that I'm desperately trying to get you. Math 176 is where you really, with the proving trig identities kind of thing, where you just have to start to play. You have to start to play. If you haven't already been playing with math, and normally people aren't, because they're like, it's not crayons, it's not little transform. I can't play with this shit. But yes, you have to play with it, just to see what happens. Even if you don't know why it happens, screw it. Okay. So, the first part of chapter 10 is going to be really nice. Should be. It's just going to be solving systems of equations. Even section 10.2 is solving systems of 3 equations. I got a little handout for that in case you've forgotten how to do that. We're going to very quickly do some little examples, and then I want to show you the only real new thing out of section 10.1 and 10.2. So very quickly, how do we solve this? Oh, I guess I should make it work. Do I like it? Okay, if I did that right in my head, it should come out nice. We'll find out. What methods do you guys know to solve this? There should be a total of 3 by hand methods we can use. Substitution. All right, let's start there. So how do you do substitution? Yeah, which one do you want to solve for? Yeah, the one that's already almost by itself anyway. So if you take 2 and solve for y, what can I do then? Yeah, take 1 and say it's 4x minus 3 times y, but I know what y is. So like when I teach this to my like math 90 students or something, I tell them it's sort of like you're a detective trying to put together clues. So that's why you go out and talk to people. You try to get as much information as you can. You say, how long was the body there? How far did the blood splatter? Hey, Dexter, come over here. What's this mean? Don't kill anybody else. And so I have all this information. I want to somehow use them all together to come out with the solution, to see who killed who. So I need to use one piece of information in the other one somehow. I need to use them together somehow. So if this piece of information tells me that y is this, right? Suspect A was at the gym, and then I put it inside the other one. Well, suspect B told me that he wasn't at the gym. So I got to put this into the other one. So y is 3x minus 5. You can do it, Jeff. There you go. So I'm using this equation here. 4x minus 3y equals 5. And then, of course, what can I do? So now I've got one variable in the whole thing. I can actually solve it. So you get 4x minus 9x plus 15 equals 5. Get negative 5x equals negative 10. I get x is 2. Yay! And, of course, you don't stop there because there's 2 unknowns, right? There were 2 perpetrators. Plug it back in. So And you always, when you do substitution, you always have an equation that's better used. So y equals 3 times 2 minus 5. Y equals, you can do it, Jeff, is it 1? I did it, did I do it?
Yeah.
Yes. You did it. Which really means what? What really is the answer?
2, 1.
Beautiful. The 0.21, because the most basic way to solve a system of equations is to graph it. Here's a line, there's a line, where do they meet? Right? You guys still know with me? Because when I graph the line, if I graph this line, I don't really feel like graphing this one. If I graph this line, what does that mean? No. If I graph this line, what does that mean? What have I just done if I graph it? No, it is a function. I didn't make it a function. And he's like, I'm just trying, man. What the hell? It's a weird-ass question you ask. How many answers does this have? Infinite number. So if somebody said, what are the answers to this? And you had to tell them they have a gun up to your head. Do you want to just start listing off answers? You better tell me all the answers. Shit. Right? I'd much rather say, let me draw you a picture and you can find all the answers you want. So I'd go, if you could do it, Jeff. So 3x minus 5, so down 5, up 3 over 1, blah, and then I say, find any answer you want. There. So when we graph anything, we're graphing all the solutions to that equation. You guys with me? In whatever dimension I'm in. Today we will get into the third dimension. We'll finally get off the paper. We'll stand up. We'll say, I'm not in flat land. I'm actually somewhere. I ain't worried about me now. I'll be okay. I like this thing again. We'll sit near the door. You guys, I don't know if you guys ever realized that. I mean, that's the quickest way to answer the question. What are the answers to this? There. That's the quickest way to answer. Well, what about this answer? We'll go find it. Get whatever answer you want to. Put the gun away. Why do you have a gun? What's going on? Right? So when I come in with this guy and I graph him, they're going to meet at the point 2, 1. Probably something like that. They'll meet at the point 2, 1. Yay! Alright, cool. Now obviously, we will get to the point where we have more interesting graphs. If I graphed a parabola and a line, there could be 2 points. 2 answers. Or there could be no answers. Or there could be 1 answer. Can't be more than that. Does that make sense? Can't have more than 2 answers for a line and a parabola. Alright, good. If you think about it, cool. Alright, stop thinking. Alright. So that's a little bit beyond, but the basics of section 10.1 are stupid simple. You shouldn't have any trouble. It should be nice. Oh, thank God, a little breather. Awesome. 10.2, the same sort of way. Let me give you this little handout. Most of you guys should be pretty decent with this, but just in case you've forgotten. Does that look familiar, that process? Normally students balk a little bit when they first learn this, but then they're like, oh cool, it's always the same thing. That's awesome. Always the same thing. Kill a variable twice, and then you got 2 equations that have just 2 variables, no big deal. Alright, so hopefully this is okay. You can reference this if you need to. I want to do something beyond that. As always. Come on, Jeff, stop doing that shit. So, I want you to solve this relatively easy-looking matrix. Not matrix, sorry. System of equations. We're not in matrices yet. This is is one that I created, so you should know something freaky's going to happen. These are Z's. I don't want you to tell me how many answers there are. I want you to tell me what the answers are. It'll make more sense, hopefully, in a minute. Which letter are you guys killing?
Y.
Alright, those are the two best ones. Z is probably the best one. And they're not meaning anything. If you do Y, you'll come to the same answer. I'll do Z first, and then we'll see if we get the same answer with Y. What are you guys finding? You should probably have seen something. Anybody found something there?
X and E are, I don't know how to describe it. Are they undefined? Or, like, so I looked at this, and when you multiply that, they both
So you get 0 equals 0, which means... So normally when I'm solving an equation with one variable in it and I get 0 equals 0, the answer would be all real numbers. Because the answer has to be a number or some numbers. Here the answer has to be what kind of thing? What was the answer, the real answer to the two-dimensional problem we had earlier? What was the answer?
2, 1.
Yeah, geometrically, it's a point, right? So now, here's the cool thing. Now let me talk a little bit about 3 dimensions in general. So you guys should be getting to the point where you get 0 equals 0, or you should be getting to the point where you have 2 functions that are the same. So if you did add them together, it would cancel out. You guys see that? Are you guys getting that? Alright, so just a couple quick notes. Geometrically, what the hell is going on here? I don't know. Okay. So, here, just to look at this for a second. If z was 0, this would be x equals y. Is that cool? Do you guys see that? If z were 0, this is x equals y. And what does x really represent? Geometrically. X-axis. So how far on the x-axis I move? What's y represent?
How far?
How far on the y-axis I move, right? And what does z represent?
How far
If we're on the z-axis, which has got to be perpendicular to all the other axes. So it's got to be like this. You guys kind of with me? We're not going to start graphing 3D. We're not going to start solving 3D problems directly. But that's one way to interpret this, is this is living in 3 dimensions. If z is 0, meaning where am I? If z is 0, where am I? So this is the z-axis here, right? So if z is 0, where am I? You can do it.
Origin.
If x is 0, yeah, origin. And where's the origin? Is the origin here? Where is it? On the board. So if z is 0, I'm on the board somewhere. So the point 1, 3, 0 is there. Well, where's the point 1, 3, 1? Right there, yeah, right there. There it is, right there. Woo, hovering. All right, let me stop there for a second. You guys kind of with me here. I don't know if you've ever actually, somebody in some time must have taught you about 3-dimensional coordinates. Even if they have never done so. X, go this way. Y, go up and down. Z, go out or in. So negative z would be inside, would be on the other side of the board. You with me? Alright, so this is not freaky stuff yet. That's 3D. Not 4D, not 5D, not 80D. This is 3D. Alright. So stay with me. This is cool. Nobody ever explained this to me like this. I love the way that I came up with this morning. I never thought about it like this. If z is 0, x equals y. So that would be this line here. Y equals x here, right? Is that cool? If z is 1, now I've got to plot it on the same coordinate system. But what's my coordinate system now? This. So if z is 1, I'm up here. What's x equals, y equals what? Y equals x plus z. So y equals x plus 1. Let me stop there for a second. Do you understand? So if you make z 1, add y over, don't you get that equation, right? So it is the line. I'm going to graph its shadow. I'm going to graph its shadow. Its shadow would look like that. Where is it really, though? Here. It's 1 unit up. So if I make z equal to 2, I'm going to get y equal to x plus 2. That's crazy. So now the shadow is going to be here. And it's really, so this is a plane that's going like this. And then through, because if I make z negative, it's going to be negative. It's going to be y equals x minus 1, y equals x, so forth. That's kind of cool if you think about it. In fact, what I should have started with is when you first teach students about 2D, how do I plot the point x equals 1? There. Yay. Right? But what if the equation really is y plus x equals 1? So if y is 0, x is 1. If y is 1, x is 0. So you end up with a line. But what you're doing is, for y equals 1, you've got another number line. But if y is 1, what's x? 0. If y is 2, you've got this number line. If y is 2, what's x? Negative 1. So now you just put it all together. You say there is a number line for every value of y, there's a number line. And I'm going to plot what the value of x is on that number line. I'm taking that idea into 3D. For every value of z, there's another coordinate system. If z is 1, it's going to be y equals x plus 1. It's going to be that line. And if z is 2, it's going to be y equals x plus 2. And if I just put all those together, I'm going to end up with this plane. Maybe. So if the only thing you take away from this is what I'm about to say, I'm okay with that. Because that's all really interesting, freaky shit. But each of these equations is the equation of a plane. Right? So what you're really doing when you're trying to solve a system of equations in 3 equations, you're trying to solve, let's say I've got one equation is that wall, another equation is that wall, those are planes, right? Another equation is the ceiling. So where's the answer to those systems of equations? If it's that wall, and the ceiling, where's the answer? That point in the corner, that's the answer. That's where they all meet. But planes can do all kinds of weird shit. They can hover over each other, right? You can have two that meet, but then the third one's like, no, I don't think so. Right? Like the third one's over there. This guy, and the third one's over there. It's like, dude, you suck. So then there'd be no answer. Infinite number of solutions. All right. An infinite number of solutions, if you have your book, because they do this, they can draw this picture better. And I try to say Rolodex, but that's so old school. It's almost like saying 8-track tape now. Anybody ever seen a Rolodex? A few of us, right? Some younger, you're like, I've seen that in a museum. So the Rolodex had a spine down the middle, and it had little index cards coming off of it. So you can imagine, you have to imagine, like the middle here, so you have all these planes coming through. They all meet at a line. So I could have 3 planes, and they all meet at a line. So that would mean that there would be an infinite number of solutions. You guys got it with me? A little bit. The tiniest little inkling of a bit. Right. Trust me, you should read this section. Look at the pictures in this section at the very least. Look at the examples. So, what's that got to do with this crazy ass thing? Well, I know how many answers there are, if you've done the work correctly. So if I kill Z, let's do that first. Kill Z. So I can do 1 plus 3. 1 plus 3 is 4. Yay, Jeff. That's 4 because it's just the fourth equation up there, right? So what would the fourth equation be? 1 plus 3?
2.
2x
Plus 4.
plus 4y equals 2. And if I do 1, what am I going to do? 2 plus 3. I get the fifth equation. I have 3x plus 6y equals 3. Now both of these become x plus 2y equals 1. X plus 2y equals 1 if you reduce each of them. Now some of you guys might have multiplied, made it different signs, and get 0 equals 0, which is not good enough on its own. It tells you there's an infinite number of answers, but it doesn't tell you how there's an infinite number of answers. They could all meet at a line. All the planes could be the same plane. So then the answers would be all the points on that plane. In this case, the answer comes out to be a line. But I need to know how to represent that line. And what's really, really cool, the reason I wanted to do this immediately, as soon as I could, is we use a parameter to define what the line is. Now here, this tells me what x and y, how they relate to each other, right? What does z have to do? We don't know yet. Z is somehow related to x and y here, right? Through these equations. Now watch this. So I know, so far I've got the answer is x equals 1 minus 2y. Is that cool? So what am I going to let be the parameter t? What do you think I'm going to let equal t? What makes sense here? Because then I can immediately get the other variable. Am I going to let x be t or am I going to let y be t? Y. Because then what's x? If y is t, what's x? 1 minus 2t. Now take a minute, think, collaborate, figure out what z is. You know what x is, you know what y is, so you got to know what z is. I always want somebody to get really exasperated. Go, z is freaking m, alright? Oh. What do you want from me right now? So which one of these do you want to use? I would probably like to use. Yeah, solve for z. What do you get if you solve for z?
3t minus 1.
Yeah, let me catch up to you. So z is y minus x. Is that cool? Add the y, subtract the x. Is that cool? So z is y minus x. So z is 3t minus 1. So this is kind of cool. the answer to this system of equations. We can now be much more precise. And I know you guys were cool with not being precise. I understand that. And I don't care. Because now we can be and you will be. Right? The answer to the system of equations is every point that looks like this. X, Y, Z. So any point like that. So give me a value of t. If t equals what? 2. What point would this be? Negative 3. 2.
Negative 5.
5. So what's supposed to happen with this point? What should this point do? It should... No, not where is it. What should this point do? Sorry. What should this point do considering it's what was this again? This is all the... This is one specific. So what does it do? It works in all 3 of those equations. Right? Let's see. Let's see if we can trust Jeff on his fully medicated day here. See if any of us can trust Jeff. So we plug in the number 2. I don't care. Twice negative 3 plus 2 plus 5. It better come out to be 1, right? Negative 6 plus 7 is, holy shit. And that's not surprising. But I want you to realize this. That is one example for a t of 2. And t can be anything. You can make t anything you want to do. You can make t square root of 11. Whatever point that ends up with works in there. It's awesome. How many letters did it take to describe the answers? 1. Therefore, it is a line in 3D. Stay with me now. We're going to immediately do one more example where we get 2 freaking parameters. Because I told you about that before. Right? And then we'll probably head out so your brain can come back down. Hopefully you're all up there with me somewhere. Alright. So now, be careful. When you get 0 equals 0, you can't just say infinite number of solutions. You have to tell me what are the solutions in a form like this. The solutions are everything that looks like this. And why are there an infinite number of them? Because t can be anything. So here's a very, very simple way to make an equation with 2 parameters. Stay with me now. Come on, this is where math starts to get really freaking cool. Yeah, for you, man. Alright. So here's a really easy way to do it. X plus 2y minus z equals 1. 2x plus 4y minus 2z equals 2. Where did that come from? Where'd that second equation, where did I get it from? I just did what to the first one? Double. Right? You with me so far? So the third equation is going to be 3x plus 6y minus 3z equals 3. Where to get that third equation?
Times 3 to the first.
Triple equation, yeah. I like it. You guys with me so far? So now, what's going to happen here? What's going to happen here? If I double this one and subtract it from 2, what am I going to get? Zeros. If I triple this one, subtract it from 3, I'm going to get zeros. So how many real independent equations are up there? 1. Whereas on the last one we did, there were 2 real independent equations. Some of you guys are kind of with me. So this is like me saying, let's figure out how old I am. I'm twice as old as Tony, and Tony is half as old as me. And you're all like, screw you. You just told us the same damn thing twice, right? I told you the same piece of information. I just turned it around. Ooh. So I told you this, and then I told you twice that. Thanks, Jeff. And then I told you 3 times that. You've already told us that. Shit, stop. I don't know if you guys are kind of with me here. Come on. I don't have 3 distinct pieces of information. I only have 1. And what does each one of these represent? It's a plane. Each one of these is a plane. And actually all 3 of them are the same freaking plane. So the answer should be all the points on the plane. And how many dimensions are there on a plane? So I'm going to need two parameters to describe a plane. So if you can write something using one parameter, it is a line. I don't care if you're in 79-dimensional space. If you have a 79 input point and they're all described by t, it's a line in 79-dimensional space. Right? Don't worry about what 79-dimensional space looks like. Don't do that. It will fry your circuits. All right. So if I the only thing I have is this. Everything else is zeros out, right? So how many free variables do I have? How many variables can I just make a number up for until I have to stop? I mean, can I just say x is 5, y is 7, and z is 13? Yay! Can I do that? Will it work? How many can I just make whatever the hell I want it to be? 2. I have to have, if I tell you what y is and what z is, I can figure out what x is. You with me? Whereas before, I just had one thing I could describe, and everybody else built off of it. So now if I say, all right, y is t, and z is s. I think I told you this before. T and s, for some reason, are always the first letters we use for parameters. T we know, s is new. Then you went, let's go backwards. So let's see, what's x then? It'll be z minus 2y plus 1. This is the equation of a plane, right? Well, all three of these together is the equation of a plane because how many letters did it take to create it? 2. Be careful. S and T are the only things that require inputs. Together, they make X, Y, Z. They make a point. And again, you can tell me what X is, you can tell me what T is, we can come up with a specific point, and it will work in there, just like we did before. So if you were working in, I continue to freak your mind out, if you were working in 4 dimensions, and your answer was a cube, cubicle kind of space, you guys kind of with me? So a line has how many parameters? A plane has, which makes sense because there's 1, 2 dimensions for a plane, there's 1 dimension for a line. A cube is going to have 3 because there's 3 directions I can go now, right? And so forth. As you increase in your dimensions, your parameters can increase also. That is just freaky. That's enough. Yeah. So stop thinking about it right now before your brain rebels or something happens. I don't know what's going to happen.
The quiz is Wednesday?
Quiz is still Wednesday, yeah. I like it.
I always write right out of your read.
Ouch. Down forever. I like it. Instead of down dog. I don't think I have, do I have anything for you? I don't think so. No. No.
So you were at home making cookies? Yeah. That's what's up. That's why I get the way to look along that thought. But I'm supposed to make some other kind of presentation, so is that ethnic?